Okay, so this is the next video, the second video on winds and the Earth. Hopefully, if you had a chance again to watch the tank and the warm and cold air, you saw that kind of convection current within the fish tank again. So basically, that is what would be expected to happen with global winds. Okay, so if I could draw the Earth really well, so this is kind of like your example of what the Earth would be like. And here is the equator at 0 degrees latitude. Now, and then the kind of at the middle here, let's say this is kind of your, 30 degrees latitude, and then 60 degrees, well, north latitude, north latitude. And then here would be your 30 degrees south latitude and 60 degrees south latitude. And then the poles are, North Pole is at 90 degrees north latitude. So what you would expect to happen is because the equator gets that kind of smallest, most direct sunlight, then therefore the air is warmer here. So as we saw before, you would expect that warmer air to rise because it's less dense, and also rise in this direction. Okay. So you would expect that air to rise because it's less dense, and also rise this way. So kind of go toward, and then you would also expect then the colder air at the poles where they get, where the sunlight is much more spread, so less of a share here. Okay, and because of that, that's going to be colder air up here, near the poles. And so that's going to be more dense, and it would sink toward, at both poles, it would sink toward the equator. So this is at 90 degrees south latitude. So this is what would be expected to happen, and we would have, therefore, winds that flow from the north, that go north and south. So winds from north and south. So, but this is not what happens because the Earth is rotating. So, since the Earth is rotating on its axis, this is not what happens. So I'm going to kind of show a demonstration here as best I can. So if I try, and see here's my kind of Earth again. Okay, now if I try to, with just kind of a, okay, if I try to draw a straight line, okay, and I'm going to start to try to draw kind of a straight line, but then I'm going to turn my paper. And you'll see that as I try to draw a straight line, that line actually curves. Okay? So even though this wasn't the perfect demonstration, since I don't have my Lazy Susan at home, so because the Earth is rotating, the air that's moving north and south curves. Okay? And in some cases it depends, but it moves either east to west or west to east. Okay, because it curves because of the rotation of the Earth. Okay, and that is called the Coriolis effect. So what actually happens, I'll kind of try to draw this as best I can, on the Earth. Okay, so here's kind of the larger, though barely fits on my camera here. So what actually happens is there's a bit of a turning of what happens with the global winds. And these are global winds, obviously. They're kind of going everywhere. So what actually happens is there's more of a cooling on the way, so you don't go fully from south to north and north to south. And when they turn, what actually happens is this. So let's see, this is 0 degrees latitude, and this is 30 degrees south. This is 30 degrees north, and here's 60 degrees north, and 60 degrees south, and then of course 90 degrees south and 90 degrees north at the poles. I'm mostly concerned between 30 and 60 because most of you are doing projects that actually involve the continental U.S., which is for the most part right in between 30 and 60 degrees north latitude. So really I'm mostly concerned up here. So what happens, first of all, is this kind of warm air here at the equator, or sorry, not at the equator, I apologize, at 30 degrees, kind of goes this way. So these are called the trade winds. And also the wind here kind of goes this way, sorry about that, and that's also the trade winds. So the trade winds, which occur from 0 to 30, kind of go toward the east. Now, what happens above us is we have what are called the prevailing westerlies, and winds are named for where they come from. So these move west to east across the continental U.S. Okay, so the prevailing westerlies, so our winds actually turn toward the east. So generally speaking, that what this means for weather is that fronts and air masses will move across us from the west to the east. So those are prevailing westerlies, which are our winds. And then what you can get also is these things that are called polar easterlies that occur from these happen from 60 to 90 degrees. Okay, and again, I'm looking mostly at the northern hemisphere here. I probably should have done the trade winds in a different color. And these will happen from 30 to 60 degrees. So these are your global winds. There's also something called a jet stream, which is another type of global wind. This is a high altitude wind. That basically occurs because of differences in air temperature as well. Okay, and this occurs at high altitudes. And if you want to find out a little bit more about some of these things in a little bit longer discussion, I've included a video to kind of explain some more about global winds. But if you kind of generally understand that winds above us move from west to east, and that they would move north to south and south to north because of differences in temperature, and they're all convection currents, but that because the Earth rotates, and that Coriolis effect causes winds to either turn west to east or east to west, depending on where it occurs. All right, thanks a lot, and have a great day.